Hello, mentors. Welcome to Gelateria Prima, so primera or first. And here are the rules. We have 4 flavors for the scoop, the same 4 flavors for your syrup. You have to have always 1 scoop, no more nor less. And you always have to have syrup or salsa. It's mandatory. Also, the flavor of the salsa or the syrup can be the same flavor as the scoop, no problem at all. For example, if you adore pistachio, here you would have a pie square, so pistachio, pistachio. Finally, you have to choose between a cone or a cup. So how many gelatos are there? What if we had 10 flavors? And then find the secret menu. So this is what students will be do. Firstly, we'll just role play. One mentor could be the clerk here, just because it's the first store, the first ice cream store. Then the students may be the clerks. And they're just gonna play by the rules and just order things. So for example, you could say, give me, and here the order, when they order, they'll see how, in which order they make their order is not really important. All what important is the information. So that's important combinatorially. So they could first say, okay, I want a cup, I want pistachio for the scoop, and my salsa or my syrup, chocolate. So here would be. So you would charge how many dollars or whatever. Second in line could choose, for example, here, a cone, vanilla, and they would also do vanilla cream or vanilla syrup. That's also okay. A little weird, but it works in this gelateria. Then they would be trying to solve how many they are. So they would, for example, notice that let's first count without the container. Just forget about the container and forget for now about the syrup. So you have 4 choices. And they could do a table. We'll have manipulatives for this. So they could arrange these actually in a table that just emerges. They just make this table like physically with the manipulatives and make sense of the rows and the columns. And so, for example, in this part here, they would be doing, for example, let's do this last one, for example, they would be doing a scoop of strawberry and the syrup would be pistachio. And they would make sense and they say, okay, it's actually 16. But this was just for this container. So if you want to do the other container, which you don't need to, it's another 16. So they get expressions like, let's practice 16 plus 16, or 4 plus 4 plus 4 plus 4, and then times 16. Oh, sorry, times 2, and so on. So you have to be flexible in all these expressions. Now they play the, oh, sorry, before that, they actually ask 10 flavors. They don't have the flavors, but they imagine doing a big table that's 10 by 10. So that's going to be 100, but you still have these 2 containers. So that's going to be 200. So they imagine making the table. They don't have to do the representations, but it's important that they imagine that they made them. It really adds to the concept instead of just memorizing a formula and just changing the numbers. You just think about the representations, even if you cannot produce them because they're so big, but you still think about them. That's really important. Now you play the secret menu, and in the secret menu, a mentor will say, okay, if just order, if you guess the order, if you guess the secret menu set or one element of one gelato that fulfills these conditions that I have in mind, that secret conditions, I give you the gelato for free. And it becomes a game. It becomes a detective game where you gain information the more you play. So what's going to happen is, let's erase this. For example, let's say a customer orders this. Actually, let me just backtrack a little bit. Let's say a customer orders this particular and they charge some money. Okay, so it's not part of the secret menu. Let's say somebody does this and they get it for free. So, okay, some information. At any point, they can guess the secret menu. So they may say, oh, it has to have vanilla. So maybe they make another conjecture. They order something like this, vanilla. And let's say the syrup. And nope, no free. So maybe it has to be a cone, or maybe it has to do with the pistachio. So now they order this, let's say. And then it gets the free. So wow, okay, has to be free. And then they went like, okay, it has to do with the cone or not. Let's take a look. Let's try. Let's just do this pistachio again here. Put it in a base, in a cup. Nope, they charge money. So okay, it probably has to have to do with a cone. So they're guessing the rule. And then they go like, okay, what if I switch? And let's just do vanilla or whatever, whichever other syrup. They get it for free. So they're like, oh, okay, it has to be a cone, and maybe it has to have a pistachio. Can it have both? So they try. The next person in line orders a pi square ice cream, gets free. And then at some point they have to actually say the rule out loud, whichever student. This is a cooperation game, so they're together playing detectives and helping each other in the least number of rounds. So they said that the secret menu is cone. It has to be a cone and at least one pistachio. And then, yeah, I think that was it. It's a cone and at least one flavor is pistachio. If they say the rule wrong, the mentors can maybe give a hint and say, just keep trying. And then they would count how many there are. So here, what they would do is they would first, for example, say, okay, all the ones that have pistachio syrup, that's 4. And all cones, all the ones that have a scoop being a pistachio, that's 4. And a student may say, okay, it's 4 plus 4. But they are counting twice, right? So in this, there's repetition in this meta list of these two properties. So they have to remove one of them. And so the answer would be 7. And then there could be a discussion, 7 out of 32, is this reasonable for a secret menu? Or is it too many? Because you want the secret menu set to be small. So it's somehow reasonable, a bit less than 25%. But okay, it's a very generous store because almost 1 out of every 4 clients will get a free ice cream. So it's a very beautiful day in that store because it's very likely 1 out of 4, at least almost 1 out of 4 ice creams or gelatos end up being either a cone a cone and also having at least one pistachio on its DNA. So that's the Gelateria Prima in essence. This order you can flexibly do with your students. The last part, we don't have it here in the guide, but we have it here. And it's important also. It's extending by 1. So an extension example would be if we add paleta as an option. So now we have cone, cup, and paleta like this. How many new gelatis we get? And so it's just counting the extra, which is different from just having a lot of things here. So this extension is in one direction, just more flavors, a lot of flavors and how many total. But this extension is just adding 1 in one variable. And so it just grows, here it just grows, well, a lot, 16 new if you add paleta as an option. And you can reason in different ways. It's just a new table. That's what a student could say when you're looking at solutions. They said, okay, this was just for each of the containers. So if I just add paleta, I just have 16 containers. And that sort of reasoning, it's relational, meaning it's making my brain organize and kind of, connect all the parts that play into solving these combinatorial problems. I don't care about the formula. I care about understanding all the relations, what's going inside. So this really helps into that direction. So please don't skip it, this extension sample. Okay, so I hope you like this video. I hope you like playing detectives with your students. Hopefully that's a lot of fun. And see you in our next video. Goodbye.